This module will cover the concepts related to speed and velocity. So in the last module we talked about the difference between distance, which is the overall magnitude of how far we've gone, and displacement, which is how far we've gone from point A to point B. Now if we start thinking about then how fast we're going between those 2 points, whether you can base that on distance or displacement. So if we're basing how fast we're going on distance, the overall magnitude between point A and point B, it's called speed. And when we base it on the displacement, so the straight line between point A and point B, it's known as velocity. So if we cover the specific formula for speed first, you'd probably be aware that how fast you're going is a product of how far you've gone divided by the time it took you to get there. So speed equals the distance divided by time. But bear in mind that's an abbreviation of the longer formula, or more specific formula, which is the average speed equals the change in distance divided by the change in time. Now I'll talk about the difference between average and instantaneous speed in a subsequent module, but the change in distance and time is important there. And more formally, we can write that out as distance 2, take distance 1, divided by time 2, take time 1. So I'm going to explain that a little bit further with an example, and you can see a player here moving from point A to point B. So if we know the distance between point A and point B is 15 meters, so not displacement in this case, but the distance, and the time is 4 seconds, we can calculate speed using those two things there. Now I've got the full equation here, and I've just changed the distance at B, take distance at point A, divided by the time at point B, I'll take the time at point A. Now in this case, distance and time at point A are both 0, and so therefore the calculation's pretty easy. But you may have examples where your distance or time at point A might be a number different than 0. So you're going to have to go through the formal or the full equation there. So you can abbreviate or formalize as you like as you develop your skills on these equations. So the average speed then, 15 divided by 4, is 3.75 meters per second. That's the speed based on distance. So if we move on from speed to velocity, what we notice is the equations are exactly the same. It's just displacement instead of distance. So there is the abbreviated version that we know, displacement divided by time, more formalized, and then you've got the full equation there. It's all the same thing, just a more formalized version of it written out in full. So if we then look at the same example but velocity, so this time we're looking at the straight line displacement between point A and point B. So the distance was 15 meters. Overall, the displacement is, in this case, 9 meters. And if we know that displacement and we know the time, it's the same thing in the calculation here. We're obviously just substituting 15 for 9 from the previous example. So the average velocity is therefore 2.25 meters. So in this case, because the player wasn't traveling on a straight line, the speed and velocity are two different numbers, but they use the same equation just based on distance and displacement. So another important difference in velocity versus speed is that it is a vector quantity. So because it's based on displacement, it has a magnitude, and you can also measure a direction to any other point of reference that you want to put in because it's that straight line. And so I could have given you the problem like this, saying that there's a point A and a point B, and you've got two lines in here that are components of the vector, and both of those are 6.36 meters. So if those are the two components of that vector, and say we have a right angled triangle here, and I'm looking for the hypotenuse, which in this case is the velocity, then I could have used Pythagoras in this case to do a little calculation there. So it's the square root of, so it's a squared add b squared equals c squared for the hypotenuse of that triangle. So the square root of 6.36 squared add 6.36 squared is going to be 9 meters. So it's exactly the same equation, exactly the same problem, but I could have given it to you a different way and expected the same answer. We would have gone through these calculations the same, 9 divided by 4, still 2.25 meters a second. But it is important to understand that velocity is a vector and therefore can have direction, and I can give you components of that as well. So if you do want to work on these concepts a little bit more or hear them explained differently, then I'd suggest these links here as well as a number of other sources that are available to you.